So in the previous session, we talked about Unix in the first couple sessions so far. We have been talking about Unix, and we learned how to do compression and how we can save space by compressing files. So if you have missed that session, please look at the recordings. We can do a lot more with Unix, and later on in this coding instruction session or the weekly sessions, we're gonna have an opportunity to run actual analyses on biological data. But for that, we need accounts for everybody. I have to talk to bioinformatics and get an account for everybody, and then you can sign in and run analyses. So you're gonna be able to hopefully remotely connect to the bioinformatics servers at Cornell, where you can submit analyses. That's the plan for the future, but before we get there and before we can set up the accounts, we can learn a little bit about R and RStudio. In any field you are, no matter what, chances are that you're gonna need to use R. It's either R or Python, sometimes both. And I personally prefer R because I learned R first, and then I found out that there's a lot more help for people who are starting. So it's easier to learn R than Python. Python is also kind of designed for people who have some basic knowledge of coding. So because of that, I prefer R. And also I found out that anything that I can do in Python, I can also do in R. So I don't have a strong motivation to learn learn Python. But it's always useful to be able to read in both languages, even if you're not fluent in writing it. You can be fluent in writing R or Python, but it's also good to be able to read the code from both. And becoming familiar with R will help you understand the structure of Python codes as well. So do you all have RStudio installed? All set to go?
Yes, ready.
Great. Why don't you, I'm gonna start.
I think Diego's still logging on, right? Yeah.
He's trying to log in?
Yeah.
Okay, yes.
yeah.
There we go. Okay. Oh, I lost him. There he is. Okay. Hi, Diego.
Good morning.
I was just saying that we're gonna get accounts, Unix accounts, hopefully for everybody, so that we can run analyses like GWAS on the cluster. But for now, I decided to switch gears to R a little bit, and then we can get back to Unix later. Okay. So I'll share my screen here, not that screen, this screen. So I sent a bunch of files to your email, and make sure you download those and save them somewhere on your computer. And we're gonna use those files. I sent an email with this link. If you click on it, you'll find a bunch of files. These eggplant phenotyping fruits, phenotyping leaves and flowers, eggplant phenotyping location. So these three files are the ones that we're going to use today. And let me know when you finish downloading them. And save them on in a location that you can easily find. When you're done, give me a thumbs up so that I can continue. Are you all set? All good? Okay. So on my computer, I saved them under a folder called the date of today, 2021, 0712 RStudio. And these are all my files. And if you notice, these are CSV files. CSV is short for comma separated values. And if you open this in a text editor, you can open these with Notepad or whatever that is in Mac. You'll notice that these are all values that are separated by commas. And separation in the data science world happens multiple ways. Sometimes it's by tabs, sometimes it's by commas, sometimes it's by space. And as long as it's consistent, then it should work. But one of the most common ones is the comma separated ones. And each comma signifies a new field. For example, here's accession number, comma, researcher name. This is a separate column from this one. And that's identified by a comma. And CSV files, you can open them in Excel. If you just double click, Excel pops up. And it complains that some of the features, because this is a very basic feature, it might complain that some of these advanced features like highlighting and all, you won't be able to save in CSV. CSV is just for plain text. So we have our data. If you want to know how to make a CSV file, that's quite easy. You can open a new Excel page, right? Column A, for example, and column B. And here you can have a bunch of numbers. And here, again, some random numbers. And to save this, you would just go File, Save As. I want to save it on my computer, and then you have the option here to save it as a CSV. And you see that it has two options: Macintosh CSV or MS-DOS. MS-DOS is for Windows people. CSV is for Macintosh. Macintosh is for Mac people. Yeah, that's how you save it. If I save it right now, let's see where I'm saving it. Should save it on the desktop, or yeah, more options. Okay, if I save that in my current directory, if I try opening that file in a text editor, it looks like this. Very simple text and just shows commas. So that's the introduction for CSV files. CSV files are very useful in the data analysis world. And today we're going to use some of them. But I just wanted to give an introduction so that you know how to use what CSVs mean and how you can use them for working with big data. Any questions so far? Okay. So first thing we need to learn is how to set the working directory. So working directory is where your input files are and where your output files are going to be saved. The easiest way is to just go to session, set working directory, choose directory. And if you do that, then a window pops up where you can choose where you want your working directory be, and that's the working directory where you save the files that I emailed you. So you have to find that folder, select it, and at the end click open. Go ahead and do that. One more time, it's under session, set working directory, choose directory. And then after you find that folder, you click open. When you're finished, again, give me a thumbs up. Okay. Cool, thank you. So when I click open, a message pops up at the bottom here. It says set working directory, and it shows the address of where the working directory is. You can copy and paste it into your code. To open a script page, you can click on this plus sign under file, and that gives you an empty page where you can write code. And at the end, you can save all the code that you're writing. So you can save this. This will, you can actually run this in the future. You can just select it and click run, and it will run just that line of code. So instead of clicking, going like this, you can just select this and hit run. And it will save you time in the future. But yeah, you can keep it there, or if you don't want to run it, you can just add the pound sign in front of it. If you notice, when I type pound in front of this, this turns green. And at this point, this becomes a comment. It's not code anymore. The difference between comment and code is the comments are not run. So it's just there for extra information. You can add any comments you want. I can type anything I want after the pound or hashtag. And these won't have any effect. Any line that starts with a hashtag or pound sign, they won't have any effect. They won't be run when you're doing any analysis. So they're very useful for writing comments for yourself so that you can in the future easily know what each part of the code is doing, because code is kind of cryptic. After you write it, it's hard to remember what you did exactly. So writing things in plain language helps you remember what you have done. So the second thing I want to talk about is functions. Functions in R have this format: function, parentheses. So this is the structure of any function in R. So any sort of command that you want to do is going to have that structure. For example, we can talk about plot function. Plot function is written like that. And if you want to learn about it, you can type question mark plot. You can select it and hit run. And it will give you this window, which is called help window at the bottom. And you have the option to expand it a little bit by dragging these things and by clicking on the square button over here. And it gives you a lot of information about what plot can do. It gives you a simple usage, plot x, y, ... meaning that you can add a lot more options to your function. A simple plot that I can create, for example, is this. X equals 1 to 10. The other way to write this is x greater than sign dash 1 to 10. These two have the same effect. This sign, which is kind of like an arrow, it's the older way of scripting in R. They still use it, but I prefer this one, x equals 1 to 10. And there's a difference between single equal sign and double, and I'll talk about that later. So for now, x equals 1 to 10, either that or this, you can select it and run. And if you type x at the bottom here where the R codes are, it should show you what's inside that. So it shows you all the numbers going from 1 to 10. And what you just did is making an object. You created an object. And under environment, you can actually see the values for each object. Okay. Excuse me. Now we can make another object called y equals x to the third power. And we can run this. And if I type y and hit enter, it will show me the numbers. It basically takes each of these numbers and takes it to the third power. And now I can make a plot. Plot x and y. The first number that you need, the first value that you need for plot function is the x-axis, and the second one is the y-axis. So basically you're telling R to make you a plot with x-axis being 1 to 10 and y-axis being the same numbers to the third. And if you collect this, select this and hit run, you see a plot. And if you want, if you're very happy with your plot that you created, you can actually save it as a PDF. You can type PDF. You have to give it a width and height. So you give it a file name first. I call it myplot.pdf. And this yellow box tells you kind of some of the options that you need. So it tells me to give it a file name, width, and height. And the interesting thing about RStudio is that when you type the few letters of an option, it predicts what you're trying to type. So it makes typing a little easier. So width should be 5 inches and height should be 5. That's all I need. And then another thing I need is called dev off. This is a function, it's short for device off, turn off the device, meaning that you're done putting stuff in your PDF. So after plotting this, then you finish. Otherwise, it will assume that you want to keep adding to your PDF. So if you select this and hit run and go back to your working directory, you should see a myplot PDF. And if you open it, it should look like this. Is it all good so far? Any questions? If you feel shy asking a question while I'm recording, you can ask me to pause the recording. And I've noticed that when I teach in person, people tend to ask more questions than when I teach on Zoom. So I want to make sure you feel comfortable asking questions. All good? Okay. So we were talking about getting help. Here in the instruction, it says that one of the options is called type. So when you're making a plot, you can say type equals P for points, L for lines. So if I type, I do it like that, and I should use quotes. And if I select it and hit run, instead of dots, it's giving me a line. So previously it was just a bunch of dots. Now it's lines. And it says B for both. So if you type type equals B, now it has both lines and dots, which is probably the better option. And what else? C, O, overplotted, histogram. Okay, that's good. One thing that is not mentioned here, but it usually has the link to other things. So if you want to, for example, give it a title, type main equals, main meaning main title, equals my cool plot. And this has to be inside quotation marks. And if I do this and hit run, it has a title. And there are ways to change the x-axis label and y-axis label. And you can go to the help. I can never remember these things, so I have to always go back and check the instruction. Xlab is short for the label for the x-axis. Ylab is short for the y-axis label. So if you wanna give it the name Xlab, just call it days, and Ylab, call it, let's say, growth, for example. And run this. By the way, another easy way to run a single line is Control-Enter. So if you just put your cursor and click on the line and hit, I think in Mac is Command-Enter, but on Windows it's Control-Enter. And I do that and it runs this code. So now we have the days and growth as the labels. And you can give it a color if you want, which will be the color of the dots and the line. let's look at that real quick. It says see also plot default, plot from your points, lines. PAR gives you the option to adjust the margins from the top and bottom and so on. So there is a lot to do. And points has options. Color, for example, is I think one of them. Color equals red. Now all of my lines and the dot is red. And there are interesting references. If you Google R color guide, you can find a lot of cool information about, because there are a lot of colors in R, and you can pick things that you like what is this? Chart reuse, chocolate one, dark cyan, deep pink. One of my favorite colors is turquoise. So I'm gonna make a plot that has turquoise color. So I'll change this from red to turquoise. Probably it won't be very good for this plot, but it usually looks nice in the darker backgrounds. So anyways, you can pick a color, especially if you're plotting multiple things. It's good to use different colors, and this is the color guide that you can find online. Let me see what else. Any questions so far? I forgot to mention that when you want to save your final plot, the file that is open, you have to close this. So previously I made a plot and saved it as a PDF. I have to close this so that I can save a new one, unless you want to save it with a new name. In that case, there wouldn't be a problem. So you can give it a new name if you want. My plot 2, select all of these and hit run. And this time, instead of showing us the plot here, it will, sorry, it will save it as a PDF. So my plot 2, I can open this and look at my cool plot. Okay. So now that we understand how functions work, we can use a function called read.csv. This is a function that is used for importing a CSV file into RStudio so that we can run analyses. I sent you 3 files. One has locations in it, one has data for fruits, and one has data for fruits and leaves. So, sorry, flowers and leaves. So the first one is this one. Locations, you just type this name, eggplant phenotyping locations, plus read.sv. So if I want to write this from scratch, I can also do it this way. Locations equals read.csv and quotes, and just copy the name from here, the whole thing. Paste it there. And then if I run that, I have something called locations under the data tab in the environment. So here's the file. And you can click on this and it will show you a file, a data frame with the accession number, as well as the name of the species, country of origin, and for some of these, we don't know the country of origin, or we do know, but we have forgotten to add it. So it's shown by NAs, and we'll fix some of those. But for some of them, we truly don't know where they're from. For example, this one, we don't know where they're from and what species they are. So is the case with this one. So this file just shows you the species names and the locations. There's another file that we want to load. It's called leaves and flowers. So we'll type leaves and flowers equals read.csv, and then I'll copy this. And I'll run this by selecting or by doing Control Enter. Now we have another file, leaves and flowers. We can open these and look at the data. It has researcher name and information on a leaf blade length and many other leaf characters, flower colors, petal numbers, sepal number, and these are all the awesome data that our undergraduate researchers have collected over the fall and summer, or winter and summer. Okay. The other way to quickly look at the data, sometimes the files that you're working with are huge. So if you try to open them by clicking on their names, your computer will crash. So if you want to quickly just look at the top part of the file, you can use the head function. Head, leaves, and flowers. And if you run this, at the bottom here, it just shows you the top 6 rows from that file. And it gives you an idea. You can, the opposite of this is tail. And that will show you the bottom of this file, bottom 6 rows. In Unix, we had head and tail also, but we didn't use parentheses for it. We write something like this. This is the Linux format, but in R, we have to put it in parentheses. Okay. And the third file that we need to use today is the fruit file. So I'll paste it here. Locations, leaves and flowers, and fruits. So we have 3 files. What's going on here is that when we collected the data, we put them in separate spreadsheets to make it easier for us. But now we want to merge them all together. We want to have a file that has information on the location and the species name, as well as information on leaves and flowers and fruits. So we want to combine all of these together. And if you had to do this in Excel, it would take you forever, but R is gonna rescue us here. It's gonna maybe take a second to do all of this. So we use a function called merge. Merge. If you type a question mark before it, if you want to get help, you can do that. Hit run, and then help pops up. And it says these are the, by arguments, it means all the required input that you have to give it. It says you have to give me 2 data frames. Data frames are these files that we just imported. And X and Y, these are going to be coursed into one or forced to be merged into one. And by means the column that is shared in all of them. So in leaves and flowers, we have accession numbers, and in locations, we also have accession numbers. And we can use that as the shared column that we can use for merging the two. So it will be, so I'll call it temp. This is short for a temporary file. Merge leaves and flowers and locations by accession numbers. And looks like it didn't like that. There is an error somewhere. Accession numbers. I'm gonna quickly check the column names for both of these to make sure that that column matches. Locations. The problem here is that there's dot accession number. That means that there's two spaces in this file. Location, we can quickly fix that. We can open it in a notepad or text file. Oh, there isn't. I don't know why it's, probably it's a formatting issue. Anyways, we can fix it by doing this. Column names, locations 1 equals session numbers. And if I run that, then do this. The first column is accession number down here. I can do it for the other one. I can just copy paste this and change the file name, making sure that's the right thing to do. Accession number. I want my first column in this file to be accession number. Does anyone have a question? I think I heard something, but I wasn't sure if someone has a question. Also, I'm not seeing the chat. If you're putting anything there, chances are that I'm not seeing it. I'll check. Okay, we're all good now. Okay, now we can merge. What I just did was making sure that the accession numbers column match in the two. So this should work now. And in R and in many other coding languages, if it doesn't complain, chances are that you did something right. Otherwise, it will complain. So what I just did, I created a temporary file that merges leaves and flowers and locations. And I can look at it, I can click on temp, and now it's a new file that not only has data on leaves and flowers, it also has the accession number and researcher name. And it should also have the species name somewhere. And yeah, country of origin and species, it added it at the end. And there are ways to sort the columns in any orders that you want, but I'll get into that another time. What happened here is that it took the accession names from one file and the other one and only merged the rows that have those accession names. In other words, if there is an accession that is only in one of the files, not the other one, it's gonna delete that. It's not gonna delete it from the original file, but it's gonna not include it in the output. So to avoid that, you can say all is true. all equals, you can just spell out true or just type capital T. This means that we want to keep everything, even if it's in just one of the files. Okay,
Oh, Hamid.
yeah.
Oh yeah, these are the most updated files.
Yes,
Just
yeah, I'm aware of that. Thank
Okay.
you. I was using it for practice, but for people who are gonna use the files, Paul sent an email with the updated files.
Okay, sure.
Thank you. So now we can run this again with all equals true. And we have a temporary file. We can look at it. We can double click on it. It will pop up. And it has those information. We also now want to add the fruit data into this. So we can do, I'm gonna call this all data with locations. All data with locations equals merge the temp file that we just created and fruits that we previously uploaded by accession number. Quickly should check the column names. I'll type all names fruits. And again, we have that dot problem here. I can just easily fix it by saying the first column name should be accession number. And hit, you can run this. You might hear my cat meowing in the background. So we're gonna merge the temp file with the fruit file by the accession number, and we wanna keep everything regardless of whether they're present in both or not. Then select and run. Now we have a new file, all data with locations. And it has fruits, location data, and leaf and flower information. So that's how it's a very useful way to easily merge data from multiple different sources. I'll pause here for questions. Feel free to ask all the questions, don't be shy. So my goal is that you wouldn't be just copying and pasting code, hopefully. My goal is that you will be able to write code from scratch and feel confident enough that, and it's gonna be difficult when you start, so it's totally normal to feel a little overwhelmed. So you can work on it at your own pace. Okay, any questions, comments, feedback? No? I'll wait for just 1 minute to take a break myself, and also wait in case a question pops up into your mind.
In that last line of code where it says all equals, is that a T? What is that?
Yeah,
Like
yes.
a capital T?
Yes, capital T short for true. You can actually, if you want, you can type the whole thing true.
Yeah, thanks.
Sure. So, sorry, you can do a lot of interesting analyses in R, and luckily they're all free and easy to do. And also the main advantage of scripting is that you can save your script. With click-based programs, chances are that when you click on things, you just forget sometimes. It's hard to remember. Maybe 5 years from now, it's hard to redo the analysis, but scripting allows you to replicate your work very easily. And you should also know that in a lot of papers these days, when you submit the manuscript to any journal, they will require you to provide the scripts. So I encourage you, anytime you write a script, save it somewhere that you can easily find. So what we did was just scripting. We wrote some code, and if I want to save this, you can just go to File and Save, and you can give it a name, call it My First R Script if you want to, or something more tangible than, something more meaningful than that. For example, phenotyping, something like that, and .r. If it's an R script, always save it with .r so that you can remember what you did. Okay. So I wanted to show you some of the cool plotting functions. For example, if you want to look at the distribution of fruit weight, you can type hist. Hist is short for histogram. So hist parentheses, and then you write all data. I just write all underline D, and this pops up. I can just click on it. It auto completes. And $sign in R means the column. So when you type the $sign in front of the data frame name, it shows all of the columns that you can select. So I'll select fruit width, or I can type it if I want fruit weight. And I also want to, for now, let's look at just fruit weight. And if I select this and hit run, there is a distribution. So this is a histogram. Of course, you can change the name. Instead of calling it histogram of blah, 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 you can write main equals or fruit weight. And rerun this. Now you have a more meaningful name. And so with histograms, it just shows you how many from what range of values you have. For example, here it says you have 30 fruits that are between 0 and 50 grams. And this is just keeps going down. And we have a few that are kind of like outliers toward the end here that are about 2 of them or 3 of them that are above 500 grams. So like more than a pound, which is interesting. So that's one thing you can do if you want to quickly do it for another thing. Like fruit width, you can just copy paste the code and type fruit width and change this to width and run that. And looks like fruit weight and fruit width are showing the, oh, sorry, I made a mistake.
Thank you, wrote.
Yeah, right, thank you. Yeah, I made a mistake. So this is fruit weight, this is fruit width, and the width the majority of them, or almost all of them, are in this range with an outlier 1500. And this is a quick way to find whether there's a mistake. When you get a distribution like this, chances are that there's been a mistake, a typo in the data, and then you can go back and look why there's only one fruit that is this huge. 1500 doesn't sound like a reliable or reasonable number for fruit, so we have to check that. And yeah, you can do all kinds of analysis. You can do correlation analysis if you want. We can plot things against each other. For example, we can plot the fruit weight against fruit width. So I'll copy that. And if I run this, I see something like this. This outlier is kind of messing up the plot. We can do fruit weight with something else, maybe fruit length. So here on x-axis, we have the fruit weight, and on y-axis, we have the fruit length. And it kind of gives us a rough idea that maybe there is a correlation, because as you go up in fruit weight, the fruit length seems to go up. So between length and width, there might be a correlation, which makes sense. Like the longer it is, maybe it weighs more. But we want to also know how much of correlation we have. So there's a package called Psych, and it can be used for correlation analysis. We have to install it first because it might not be on our system. So in R, a lot of times you're gonna need to install packages. Chances are that RStudio doesn't have it already. So the easiest way to do it is type install packages and then quote Psych, the name of the package that we want to use, and hit run. And this stop sign is going to pop up, meaning just wait, don't do anything until it installs it. And it gives you information here. You can check to make sure that everything is going well. Hopefully it will download it and download and install it within a few minutes. You can go ahead and install it on your computer also.
It said it's not available for this version of R for me.
Oh,
It said a version of this
yeah.
package for your version might be available elsewhere.
When have you installed your RStudio?
What would you say?
When did you install RStudio?
Earlier today.
Oh, okay. Sometimes when there's a new version of R, the packages haven't been made for it. That's okay if it doesn't work. There are other ways to do correlation analysis. Maybe I'm glad you told me that, because there are ways to do it without installing packages, and that probably is better because everyone can do that. So it installed it right now. Just to demonstrate, I'll show you how it works. But I'll show you another way to do it also, which doesn't require installing that package. So pairs panel. So after you install it, you have to load it by typing library psych. And then pairs panel. fruit length and all data fruit weight. Okay, this didn't work very well. Let's see.
Wait, I'm still working, figuring it out.
Sorry, what?
Oh, sorry, I'm talking to Diego.
Okay. Okay, so I'll do the leaf blade length and leaf blade area, columns 3 and 4. So in R, I mentioned that dollar is the sign for column, but the other way is to use brackets. With bracket, the first number, so bracket has this structure, open and close bracket with the comma in the middle. The number before comma is gonna be the rows. And if you leave it empty, that means all of the rows. And the second number, the number after comma, is the columns. So here I'm gonna say 3 to 4. Columns 3 and 4, I'm trying to do a correlation analysis on column 3, leaf blade length, and column 4, leaf blade area. And I'll hit enter, and it pops up a very cool plot and shows you the R-square value. So this is near 1. It shows you the distribution of leaf length as well as leaf blade area and the correlation between the two. So it's very useful. And you can save it if you want. Again, just copy paste the PDF command, but make sure that you change the name. So this one here, and feel free to change the width and height. I'll call this one correlation plot. So if I run this now, it will save all of this output into a PDF. And I can check it. Correlation plot. There we go. So a nice feature. The easier way that doesn't require installing packages is just typing correlation. Core X value could be this data frame, dollars, leaf blade length, and the same thing with a different leaf blade area. And if I run that, okay, it looks like I've forgotten how to do correlation analysis. Correlation. Does anyone know? Okay, we can try this one. Let's see. Install Hatchet package. Sierra, would you try installing this one?
Yeah, one sec. Let me try.
and after it's done installing, you have to write library. Everybody else can do it the same, because this looks like it has a very interesting output where it shows you correlation as a heat map, where the red means there's a strong positive correlation and blue means strong negative correlation. And that can be very useful, especially when we're looking at a lot of data. Were you all able to install it?
I'm getting it in now.
I think so. It has like a little red, it's in
Will you
red
show me?
on the bottom. Yeah.
Let me enable sharing real quick.
Yeah.
Okay, go ahead.
I think it went through. Like this is red, but
Yeah, cool. Yeah, looks like it did. Awesome. Thank you. Okay. So you can load it by typing library core plot, and then you can load this other library that should be installed already. It's called R color brewer. So it's it's a function that helps you pick colors. And then this is the function. So this one, empty cars, it's data on cars. A lot of R versions come with some example data for people to play with. And empty cars, if you just write it and open it, it shows you some data. It's just example data that's already present on your R. It has different car versions, Mazda and Mercedes, Toyotas and stuff. And in this case, looks like it's doing a correlation analysis. You can type it all in one line. So that, and then get the plot. It shows to you the correlation between these. And so that way we know that it works. And then we can change it for eggplant. And we want to do correlation between, instead of cars, we can do eggplant phenotyping. I know we're out of time, so I'll try this one time. If it doesn't work, then I'll let you go, but I'll play with it a little bit later and tell you how to do it. So instead of empty cars, we do all data with locations and columns 3 to 4, let's say. And okay, there was a problem because it says there are NAs in the in our file. Because we have NAs, the correlation analysis fails. There are ways to remove it, but I'll talk about that later. So that's it for today. Thank you very much. If you have any questions, let me know, and I'll upload the video later today. Also, I want to just remind you that we need to go to the greenhouse tomorrow. I'll send an email about that. Any questions on the things we covered?
No.
Okay.
Well,
All right. Hopefully next time we can cover more advanced topics.
okay.
Thank you all.
Hey, Ahmed,
Yes.
can you go up to the code that you put in after you did library psych?
This.
So once you do library psych, this
Uh-huh.
is you running the package that you downloaded. And then what did you write to bring up the correlation analysis?
Pairs.panel is this. So you can just run that. When you run that, it gives you this.
Okay.
And it says you're doing a correlation analysis between the third column and the fourth column, which the third one is leaf. Let's check it real quick. So the third column is leaf blade length, and fourth column is leaf blade area.
Um, then okay. Here's
If you share your screen, I can help you better.
okay.
Let me
Yeah.